physical magic, whether it is together, is magical. Let's enter question 11. A student investigates the speed of trolley as it rolls down the slope. So basically you have a trolley and the slope and it's rolling down. As illustrated in the figure number 1, the speed v of the trolley is measured using a speed sensor. So you have some sort of device here called a speed sensor to actually measure the speed of object for different values of time t that the trolley has moved from rest. So it starts from rest. U with a 0 meters per second. In this case, U stands for initial velocity. Figure 12.2 shows a relation with t of v. So you have a graph that looks like this. Dotted, and then we curve at the top, v meters per second, and time per second. A. Use figure 11.2 to determine the acceleration of the trolley. So you have to find the acceleration of the trolley and the point on the graph when t is equal to 0.80 seconds. If you actually checked at 0.80 seconds, it's actually on the curved slope. So how do you find acceleration of curved slope? Quite easy. You will have to draw a tangent. Okay, so you draw as big a tangent as you can, and then you take 2 points on the tangent. Let's call these points A and point B, and then you find the gradient, and that will be your acceleration. So acceleration equal to gradient of velocity time graph, which is just delta v over delta t. So put in your values for your v, put in your values for your t. This is graph, so you're looking for a range of around 1.6 to 1.8 meters per second squared. That means in this case, every 1 second, you're looking at 1.6 to 1.8 meters per second increase. Then V1. State whether acceleration is increasing or decreasing. So they want you to state, so this is a state question, whether acceleration is increasing or decreasing. For values of t, when t is greater than 0.6 seconds, they want you to justify your answer by reference to graph. So you can justify with reference to the graph. So if we look at the graph, at t 0.60 seconds, what it implies is the slope of the graph is actually decreasing. We know gradient represents acceleration. Another word for gradient is slope. So if your slope decreases, means indirectly your acceleration will decrease as well. So therefore, the answer here, because slope is decreasing as t gets greater than 0.6 seconds, therefore acceleration is decreasing. Okay. Again, the slope or the gradient represents acceleration. When the slope is getting less steep, means your acceleration is also decreasing. So to suggest an explanation for this change in acceleration, they're asking explanation. Why does your acceleration in this case Remember again, what is an experiment? It's about an object moving down a slope. If you think about under normal circumstances, shouldn't the acceleration increases? In this case, decreasing. And it only means one thing. A standard favorite answer, which is A, resistance increases with speed. For example, if you're standing still, okay, you're standing still, do you feel any air resistance? No, you start running faster and faster. You feel the wind or the air getting stronger and stronger, trying to slow you down. That is what it means by air resistance. The faster you go, the air resistance will increase. The slower you go, air resistance will slowly decrease until you are stationary and you feel no air resistance. Okay. Another good example is running through water. You stand still in the swimming pool, nothing happens, but if you try to run through the water, it gets harder and harder to run as the faster you move. So remember this fact, because it's quite well known for a 1 mark question that asks, hey, how come this happens? Usually the answer is this air resistance increases with it. So I hope you understand this video. If not, please replay this video again.